Hello everyone. Good morning and good evening. So people are joining us from different parts of the world. So we will wait for 2 and 3 minutes, then we'll start. So most of the peoples have joined and we are almost on time. So I think we can start. So my name is Himanshu Gehlot and I am working with programmers.io since last 3 years. And today we are going to discuss about the opcodes that are being used for the file operation. So let's move to the first slide. So today we will discuss about the introduction of file handling opcodes. So where we will learn about the basic information about the opcodes that are being used in file operation. Then we will move forward with setll and setgt opcode. So the both opcodes will be used to position the pointer to the file. So we will discuss about on both the opcodes in the next slide. Then third will be the read, read-e, and read-p. All the three opcodes are used to read the record from a file. Then we will move to the chain opcode. That will be the combination of setll and read-e opcode. Then we will move further with the advanced file operation that will contain the different combination of setll and setgt opcode with the read opcodes. Then we will learn about how to write the record in a file, how to update a particular record, how to delete a particular record from a file. Then we will talk about the error handling part, how we can handle the error while doing the file operation. Then we will move forward with the read n opcode to prevent the lock while reading the file. So we'll discuss more about it as well. So let's move forward. So introduction of file handling opcodes. So basically the file handling opcodes are commonly used to perform the several operation on the files. The files will be including like physical file. We can do this type of operation. We can do the operation on logical files, display files, and printer files. The basic operation that we are going to do is read, how to read a record, write, how to write a record, how to update a particular record, and how to delete the records from the files. And then in the advanced operation, we will talk about the different combination of setll and setgt with the read opcodes, and then we'll move forward with error handling part. And the why the file handling opcodes are important. In any domain, the efficient file handling is crucial because the data management is the key part in any organization or any domain. So it is an efficient part. So we will talk about it. So first, we will talk about setll opcode. So what is setll opcode? The setll opcode means set the lower limit. So what is the purpose of setll? So whenever you will use the setll opcode, what it will do is it will position the pointer in a file, the record which is equal to the search argument or just greater than that. Suppose I have one table which have three columns: student ID, student name, and student class. Now I have used this settle opcode with my search argument. This search argument can be any value. So suppose if I have used search argument as value 1. So what settle will do, it will search for the equal record. So it will set the pointer at student ID number 1. Let's suppose if the student ID 1 is not in the file, there is only one record present, that is student ID 2. Then what it will do, it will set the pointer with the value that is greater than that. So it will set the pointer on number 2 record. So this is how the settle opcode will work. The next in the process is setgt. The full form of setgt is set greater than. The syntax will be same, the search argument value, and then setgt opcode and the file name. Let's suppose now I also have two records with student ID 1, student ID 2, and my search argument value is 1. So what setgt will do, it will position a file at a next record with a value that is greater than that. So if the search argument value is 1, then it will set the pointer at the student ID 2. So this is how the setgt will work. And the syntax for the setgt is same, setgt, then the search argument value, then your file name. And the fixed format, you have to mention the setgt opcode in CSpec, where opcode will be setgt. In factor 1, we will put our search argument value, and in factor 2, we will put our file name. Now, we have successfully set the pointers on our files. So what next we will do? After setting up the pointer, we will read the file. And to read the file in AS400, we have three read opcodes, that is read, read-E, and read-P. So what read will do? Read will read the next record from a file. And what read-E will do? It will read the next sequential record which will match with the specified search argument. Let's suppose my search argument value is 1, and I have done the read-E opcode on that. So it will fetch the same record from the file and read that particular record. What read-P will do, it will just read the previous sequential record from a file. If my pointer is on second record, then it will read the first record. Remember, the read opcode will read one record at a time. So if you want to read multiple records, you have to use your read opcode in a loop. So let's talk about the syntax for the read opcode. So free format, you have to just mention the opcode name, that is read, and your file name. Similar goes with the read-E, then file name, read-P, and file name. And in fixed format, in opcode section, you have to mention the read opcode, and factor 2, you have to mention the file name. So let's move forward with our examples. So this is our physical file. The above part is a modification log. What modification log means? It will tell us that who created this program, when this program gets created, and what is the description of this program, and what this program will do. And in modification log, we can mention that who else have changed this program, on which date it has been changed. So you can see, let me open in edit mode. First, we will mention the record format name. So name type will be R for the record format, and then we will mention the record format name. In our case, we have mentioned the record format name as file R. Now we have mentioned the three columns, that is student ID, which is of length 5, and data type will be integer. And decimal position, we are not using any decimal position, so we will took it as 0. Then we have mentioned the column student name. We have keep the length as 20, data type A for the character. And for the student class, we have mentioned the length as 2, data type integer, and no decimal position are being used, so we have kept as a 0. Now I have made the student ID as a key. Now what is a key? So basically in AS400, a key is a field or set of fields used to uniquely identify a record from a file. So from using key, we can sort the records in our specific order. You can mention the key or we cannot mention the key. There is up to us. We have one more file there, in which we have not mentioned the key here. So this physical file, we have not mentioned the key. So we will talk about how the settler and setgt opcodes can be used in a file which have specified as a key value and which has not specified as a key value. So let's move forward with our first program. It is file OPR1. So what we are doing here, it is the modification log, as I previously told you. First, we have declared a file here. So to declare a file, we will use the fspec. Then we will give our file name. We have using this file in input mode. It will be a fully procedural file. And E means it is an externally described file. We are not describing the file in our program itself. And as it is a key file, so we have mentioned as a K here, and device is disk. Now I have declared 3 variables. We have seen our physical file, right? There are 3 columns: student ID, student name, and student class. Similarly, we have declared the 3 variables here: ID, name, and class with the same attributes: ID as 5 integer, name as character of 20, class as 2 of integer. In fixed format code, after the 80th position, we can mention the comment. So I have mentioned the comment for this ID variable as student ID. This name will be represent the student name, and the class will represent the student class. Now comes to the main line calculation. We are using here eval opcode. Basically, what eval opcode will do, using eval opcode, we can provide any value to a variable. So I am changing the value of ID as 1. So I have set the value of ID as 1. Now, what I am doing, I am using the settle opcode. On which search argument? ID. And the value of ID is 1 that we have mentioned here. And then it is a file record format name of our file. So what it will do? Let me show you our records in our file. We will just simple run a SQL query. Select all from our library name and the file name. You can see we have 4 records for students: student ID 1, student ID 2, student ID 3, and student ID 4. So when we will use the settler opcode with our ID 1, so what it will do? It will set the pointer on the first record. So now our pointer has been set on the first record. Now what we will do? The next thing we are using is the read opcode. So read opcodes basically will read the file, and at a time it will read only one record. So it will read the first record. And to read all the records, we have to run this file in a loop. So I am using here do while loop. So what I have mentioned here, do while, and in factor 2, I have mentioned not end of file. That means when the file is ended, it will come out of the loop. And what we are doing, we are fetching the student name from the file and storing it into a name variable that we have created here. And then we are displaying it. In the display opcode, we have to mention the variable in the factor 1. And after displaying the name, we will read the file again. So we will read this file in a loop till the file gets end. Similar goes with setGT. Now we have set our ID as a 2. Okay. So now our search argument value is 2 or key value is 2. So what setGT will do now, it will set the pointer on the value just greater than 2, that is 3. So now the setGT will set the pointer on the third record. Now the pointer is on third record, and when we will try to read the record, it will read the third name from the file and again store in the name variable and will display it. So this is how this program is been written. And the last, we will turn on the last record indicator. And this program also can be written in a free format. So if we do the development part in VS Code, there is one facility to convert our free format code into a fixed format code into a free format code. So for that, what we will do, we will just select our code, right click, convert to free format. So this is how the free format code will look like. To explain the difference, let me select in as a comparison mode. So I will select for compare and compare with selected. So in VS Code, I can compare my two programs side by side. So in the right side, we have our free format code, and in the left side, we have our fixed format code. You can see the changes in the file declaration part itself. When you will declare your file in a free format, you have to use this DCL keyword with F, DCLF, then the file name. Here we use I for the input mode. So similarly, we have to use this keyword usage and star input to open this file in a input mode. K, it is used for the keyed because this file is a keyed file. So we have mentioned here is keyed. The variable declaration part, we have declared 3 variables, and this is how the free format part variable has been declared. So the file declared in fspec and the variable declaration in S. So DCLS ID zoned for the integer type values and char for the character type values. And the for comment, we can use 2 forward slashes. So this ID for the student ID, name is for the student name, class is for the student class. Then the mainline calculation, we do not need to use eval opcode here. We can directly set the value by using the variable name itself. So I have set ID, then setll and the read. And the same thing I'm doing here, do while reading the file in a loop and displaying it. So this is how the free format code looks like. So you can simply select Control A, right click, convert to free format. Your code will be converted into a free format code. So now let's see this program into debug mode and see how this program will function. So let's move forward in the green screen. Let me open this program. To put this program into debug, we have to use strtbg. Then we have to press F4. Let me copy this program name first. Now I have pressed F4 here. In the program, I have mentioned the program name, the library in which the program exists. So PIOINT, and then update production file to yes, and OPM source level debug to yes. And here press enter. Now we will set the breakpoints. So I am setting the breakpoint at line number 1 and come out of it. Now I am calling this program. So I just take the C option in the OPT and call it. So now this program will open in debug mode. To move to the next step, we will press F10 here. So it will come into mainline calculation. So what it is doing, it is changing the ID value to 1. To check the value, we will just put the cursor on a variable just below the value and press F11. So you can see the value is ID equal to 1. Now we are using the settle opcode on this ID, which value is 1. So now the pointer will be set on the first student ID. and it will read the name as John. So I have used here read opcode. So it will read the first name of the ID 1, that is John. Now we have come inside the loop and we are storing our name value into a name variable. So if you see the name value here, just press F11. You can see the name is John and we are just displaying the name here. So as I told you, the read opcode will read a one record at a time. To read the next record, we have to use the read opcode again. So what it will do, it will read the next sequential record. So next sequential record in our file is 2 with the name Albert. So now if I press F10, it will read the next record. And you can see the name is Albert. So this is how it will work till the file ended. So the next name will be Linda. So it will read that record. And at the last, Jacob. So it has read all the 4 records: John, Albert, Linda, and Jacob. So now we have reached our end of file. So it will automatically come out of the loop. Now, again, we are changing our value of a variable ID. We have set the ID as 2. So if I press F10 and now check the value for the ID, so it is 2. Now what I am doing, I am using the set GT opcode. So what set GT will do? So our search argument value or key value is 2. So now set GT will just set the pointer a value that is greater than the key value. So it will set the pointer at the third ID and we'll read the name Linda. So we have just read the record, come inside the loop. Now if we check the value of the name, so it is come as Linda. Then we will read the next record. So the next record will be our last record, that is Jacob. So it will display the Jacob. And then it will come out of the loop. And the last record indicator is on, and the program will finish. So this is how the setll and setgt works with the read opcode. So there are different combination of setll and setgt. We can use read, we can use read E, and we can use read P as well. So let's move forward with our next example. Okay, so here we will talk about the read E opcode. So the same, we have declared the file here in the input mode, and it is a keyed file. Same 3 variables we have declared again: ID, name, and class. First of all, what we will do, we will set the ID as 3. So now what it will do, it will set the pointer on the third record, because setll will set the pointer on the value that is equal to the search argument or just greater than that. And read E opcode will make sure that we will read the same record that is specified in the factor 1. So it will read the same record as 3. Now, if we want to read the same record in setgt, we will use read PE opcode. So what read PE will do and what read PE means basically. Read used to read the record. Read P will be used to read the previous record. And read PE will read the previous equal record present in the file. So I have set the ID as 3. So now the pointer will be set on the 4th record, because setgt will always set the pointer the one value greater than that. Now we want to read the exact same record, so we will use read PE. So it will read the previous equal record, that is 3. So if you see here in our file, third record will be written as Linda. So now let's put this program into debug. Before putting this program into debug, we have to and the debug program that of the previous program. So whenever you use the command strdbg, after completion of debug, you have to use the nDBG on the command line. Okay, so just copy the name of the program. So we'll just double click it, copy it. If you press F9, you will see the previous commands that we have used. So I will just F4 on this strdbg command and we'll just change the program name and press enter. Again, we'll set the breakpoint at line number 1. We'll come out of it and then we'll call it. So our ID has been set as 3. So if you see the record, our ID has been set as 3. Now setll will set the pointer on third record and read E will read the matching record. So our third record is named as Linda. You can see here. So if I press F10 here, you can see the variable value is Linda, and we are just displaying the value here. Now, again, we have set our value ID as 3, and we are using setGT opcode. So what it will do? It will just set the pointer one value greater than 3, that is fourth record. Now, what we will do? We will use readPE opcode. What readPE opcode will do? It will read the previous equal record. So the previous equal record is this one. So it will also give us the student name as Linda. So if you check the name again, the value is come as Linda. And the last record indicator is on, and the program will be ended. So this is how the setll and setgt works with readE opcode. So similarly, if you want to see this program into free format, I can just select all the program, all the source by pressing Ctrl A in VS Code. Just right click, convert to free format. So ID equal to 3, setll on the ID, then the record format name, and then we have used the readE opcode. And we have transferred the value of student name into our local variable name, and we displaying it with the dsply opcode. Similarly with the setgit. So this is how the free format code will look like. So moving ahead with our next example or next combination for the setll and setgt opcode. So the next combination is setll with readp and setgt with readp. Readp will always read the previous record. Wherever the pointer has been set, it will read just the previous record. So in this case, we have changing our ID value to 2. Now, we will set our pointer on this search argument value that is 2. So our pointer will be set on the value 2. Now, if I use readp opcode, it will just read the previous record that is student ID 1. So if you can see, our pointer has been set on line number 2 or record number 2. When we use readp opcode, it will just read the previous record present in the file that is student ID 1. Same goes with setgt. We have changed the ID value to 1. So it will set the pointer greater than 1. So firstly, it will set the pointer greater than 1, that is 2. Now, if we use readp opcode, it will again read the previous record present in the file that is student ID 1. So this is how setll and setgt works with readp. So let's put this program also in debug mode and see how it is work. So first we will do the nDBG. We'll copy the program name, F9 to use the previously used command. Then just press F4, paste the program name here, press enter. Set the breakpoint at line number 1. Come out of it. Now call the program. F10 to move the next step. So we have changed our value of ID to 2. You can see The value of ID is now 2. Now the next step, we are setting up the pointer on the record 2. So now our pointer will be at line number 2, student ID 2. Now we are using the read P opcode. So it will read the previous record present in the file, that is student ID 1. So if I press F10, the name will be John. That is the student ID 1. And we will just display it. Now in the setGT, we are again changing the ID value as 1. So now if I check the value of ID, it is 1. We will set the pointer first. So we are using setGT. So it will set the greater value. So it will set the pointer on the second record. Now, if we want to read the first record, we will just use read P. So it will read the first record from the file. Again, if you see the name, it says come as John. And then we are setting on the last record indicator and will come out of the program. So this is how the read P opcode works. So first, let's move forward with our PPT. So we have talked about read, read read P. Now we will come to the next opcode, that is chain. Basically, the chain opcode is nothing but a combination of settl opcode with read. So basically what settl will do, it will just set the pointer on the value that equal to the search argument value or just greater than that. And read opcode will make sure that we will read the same record present in the file. So the chain retrieves a record from a file based on a key on a search argument value, and it is a combination of settl and read. The syntax for it is same. We will use the chain opcode, then the search argument value, and the file name. In the fixed format, we have to use the cspec. In factor1, we will use the search argument value. In opcode, we will use the opcode chain. In factor2, we will use the file name again. So let's see the example of it. So this is the example of the chain opcode. So what we are doing, we have again mentioned the file here in the spec. In the input mode, we have declared all the 3 variables, and we have set the ID as 1. So as I previously told you, the chain will be the combination of settl and read. So we do not have to use the read opcode here. We will directly use the chain opcode, and in factor1 will be our search argument value or key value and the record format name. And then we'll read the student name and we'll move into our local variable name and we'll display it. In the free format, it is similar to, we'll set the ID equal to 1, the chain opcode, then our search argument value, then our record format name. And we'll read the student name and we'll store into our local variable name and we'll display it. So this is how it will look like in a free format. So let's see this program into debug mode. First, we'll do the ndbg for our previous debug. Just copy the name, program name, F9 to use the previously command. Just paste the program name and press enter. Set the breakpoint at line number 1, come out of it and call it. So we are setting the value of ID as 1. So we have set the value of ID as 1. So now what chain will do, it will set the pointer as well as read the exact same record from the file. So in our case, we are doing the chain opcode on the ID value as 1. So it will set the pointer on first record and will read the name as John. So it will read the record, and if you see name here, it will be John and will display it. And we will on the last record indicator on and will come out of the program. So this is how the chain opcode works. Moving to the next program, we have two more combination for the settle and set GT. So let's see those combination. So here I am using star lowell and star highwell. So what star lowell and star highwell will do? So star lowell with settle L will set the pointer on the lowest value of the record, and then we'll read that particular record and we'll display it. But in case of highwell, it will just set the pointer at the highest record. Let's suppose we have the key value as ID. So if we see the record in our file, we have highest record is 4. So highwell will set the pointer next to the fourth record. Means it will set the pointer after the fourth record. Now, if we want to read that 4 record, we have to use read P. If we will use read, then it will come out of the file. It will not return any value. But if we use read P opcode, it will read just the previous record of the fourth. So let's and one more thing, the star lowell and star highwell can only be used in a file that is a keyed file. If your file is not keyed, we cannot use star lowell and star highwell. There is one exception in there. So let's put this program into debug and let's see how it works. So we have and the dbg for the previous debug program. Just copy the program name. So just press 4 in start debug command. Paste the program name. Press enter. Set the breakpoint as 1 and come out of it. Now just call this program. So first, we are setting up the pointer at the lowest value available in the file, that is 1. So it will set the pointer at the first record. Now if I press F10, we are using the read opcode, so it will read the first record. And then we will move the student name into our name variable, that is John, and we'll display it. Now we are using settle L with star highwell. So it will set the pointer on the highest value or just greater than highest value. So it will set the highest value is 4. So it will set the pointer after the fourth record. So pointer has been set. Now we are using read P opcode. So as the pointer is set after the fourth record, so read P will read the previous record, that is fourth one. So name will be Jacob will be displayed. So if you see the name, it is Jacob. So this is how the star lowell and star highwell works with settle. Move forward with our next example. What if our file is not keyed? If we see our this file OPR1, there is no key value here. And if you want to use settle and set GT opcode on a non-keyed file, how we can do that? So let's see that one. So this is the example of star start and star end. So if your file is not keyed, so in place of star lowell and star highwell, we will use star start and star end. So it will read the record from the beginning, and star end will read the record from the ending. So first we will mention the file in the fspec, that is file OPR1, that is our non-keyed file. So here we will not mention the K for the keyed. Everything else will be same. The variable declaration part will be same. First, we will set the pointer on the at the start and we'll read the first record and we'll display it. And star end, the pointer will be set after the last record. And when we will use read P, it will read the last record because the pointer has been set after the last record. So read P will read the last record. If you want to see this program also into the free format, so this is how it will look like. Settle L, then the keyword star start and the file name and the read opcode and the record format name. So let's put this program also in debug. So first we will do the ndbg, copy the program name, press enter, set the breakpoint on line number 1 and come out of it. Now just call this program. So first it will set the record on the first record and will read it. So name will come as Albert, because let me show you the record in our non-keyed file. So non-keyed file, we have first record as Albert. So it has read the first record as Albert. Now we are setting up the pointer using star end. So what it will do, it will set the pointer after the last record, means after the third record in our case. And we will use read P. So what read P will do, it will read just the previous record, that is third one. So it will read the name as Lily. If I press F10, see the name as Lily and will display it, and then will come out of the program. So these are the different combination for the settle L and set GT with star low L, star high L, star start, and the search argument value or a key value that we have seen. So let's move forward with our PPT. So this was the advanced file operation where we have seen the combination of settle L, set GT with different read opcodes with read, read E, and read P. The next slide is about the file operation, how we can write the record into file, how we can update a particular record, and how we can delete a particular record from a file. So the write opcode is used to add a new record to a file. The format syntax will be same. You have to use the write opcode and the record format name. The C spec, in the opcode section, you have to use the write opcode, and factor 2, you have to write the record format name. And what update opcode will do? So update opcode is used to modify an existing record that has been read into the program. So if you are using the update opcode in your file, you must have to read your record first. Which record you want to update, you have to read that particular record first. Then only you can use the update opcode. Same goes with delete opcode. First, you have to read the record which you want to delete. Then you will use a delete opcode to delete that particular record from a file. So let's see the example of these ones. First is write opcode. So first we will declare our file in fspec. Here we have made only one change, that is A. A means whenever you will add the record in a file, we have to use that A keyword here. The variable declaration will be same, ID, name, and class that we have declared previously in our previous programs. Now what I am doing, I am setting the student ID as 5, student name as Kathleen, student class as 10, and then just using the write opcode and in which file I want to write this record. So I have to specify the record format name of that particular file. So in our case, the record format name is file R. And these are the column names that we have specified in our PF. So if I show you our PF, our keyed PF, these are the columns, std ID, std name, and std class. And these are the record format. And finally, we are displaying the success message that is record is added. To see this program into a free format, just select all, convert to free format. There is no much change. We are just not using the eval opcode. We are directly mentioning the values of student ID as 5, student name as Kathleen, student class as 10, and then writing the record and setting up the last record indicator. So let's put this program into debug mode. First, we will do the ndbg of our previous debug. Copy the program name. Just paste it. and we'll call it. Before calling this program, let's see the records present in our file. So our keyed file is file OPR in PIO-INT library. So currently we have 4 records, and now we are trying to add one more record with student ID 5 and name as Kathleen. So we have set the ID as 5, name as Kathleen, class as 10. So you can see now the ID is 5, name is Kathleen, class is 10. And then we are writing the record in the file and then displaying the record added, and will come out of the program. So now again, if we see our particular file, you can see one record has been added. The student ID 5, name as Kathleen, and class is 10. This is how the write opcode works. Move forward with 2 more opcodes, that is update and delete. To update any record in a particular file, we have to mention the file in update mode. Previously, we are used to use here I as an input mode. So now we are updating the file. So we will mention here as U. So to update a particular record first, we have to read it. So what I'm doing here, I am reading the 5th record here and using the chain opcode. So what this chain opcode will do, it will read the 5th record which have student ID as 5. Then what we are doing, we are just changing the name as black, and we are using the update opcode with the record format name and displaying the message updated. So first we will read the record, we'll set up the new name, and we'll update the file. So currently the name of student ID 5 is Kathleen. So let's put this program into debug and see. Just copy the program name. And calling it. So first we have set the ID as 5. Now we are reading the same record which have student ID as 5. Now we are changing the name from Kathleen to Black. So if I press F10 and see the student name, so it is Black. And the update opcode will update the file. And we are displaying the success message as updated. So if we see the record in our file, it will show the name as Black in place of Kathleen. So our particular record has been updated. The delete opcode is exact same to the update opcode. In place of update, we will just use the delete opcode. So instead of updating the record, it will delete the record from the file. So you can see, just in place of update, I am using the delete opcode. In the name, I am specifying the success message as record deleted. So you can also mention your success message into a particular variable and can display it. So we are chaining the ID number 5. So it will read the particular student ID number 5 record. And then using the delete opcode, we will delete the record from the file. So let's put this program also into debug. First, we will do the ndbg, copy the program name, paste it here, set the breakpoint, come out of the program, and call it. So currently we have 5 records in our file. We are going to delete this 5th record. So first, we will read the record using the chain opcode. And then using that delete opcode, we will delete the particular student ID 5 from our file. And we'll set the error message or success message as record deleted, and we'll display it. So now if I check the value in our file, you can see the 5th record is deleted. We have only 4 records left. So this is how the delete opcode works. Moving forward with our next slide now. So we have read about write, update, and delete. So the next file, option is error handling. How we can handle the error in our RPGL program in file operations. So there is a opcode extender is used, that is E, that is used just after our opcode name, two parentheses, and then the E mentioned here. So let's see the example of error handling in our program. So as I previously told you, to update any record in a file, we have to first read that record. So what I am doing here, I have set the ID as 8. Doing the settler operation on that particular ID. Now I am not reading it. What I am doing, I am directly trying to update the file. So if I do this way, it will throw me an error that you are trying to update the record before reading that particular record. So to handle this error, we will use that E extender. And then in if loop, we will mention percent error. So percent error will, if the error is captured, then it will come inside the if loop and will display the message as error and will come out of it. So the program will not end it in an error. So first, if I show you how the error will look like in this case. So I will first change this program. I will not use update E first here. I will remove the E extender and will compile it. And will call it. Or let's put this program also in debug of the program name. Paste the program name, the library name, update production file to yes, and OPM source level debug to yes. Set the breakpoint at line number 1, come out of it. Now I'm calling this program. So I have set the ID as 8. I'm setting up the pointer on the 8th record, but I'm not reading the record. I'm directly trying to update the record. So if I press F10 here, you can see we have received an error. Update or delete in file without prior input operation because we didn't read the file. So it program is ended into the error. Update or delete in the file without prior input operation. So to avoid such type of issues, we use the E extender. So if you use E extended here, save it and compile it. Now put this program again into debug. First, I will do the NDBG, then strdbg. Set the breakpoint on line number 1 and calling it. So this time you can see it will not throw the error. It will handle the error and will come is display the message as error because we do not have the ID 8 present in our record file. So this is how the program will not abnormally end. So this is how the error handling part will work. So come to the next slide, that is read N. So what is the read N opcode? So basically the read N opcode in IBM I series AS400 is used to read a record from a file without locking it. Let's suppose we are reading the file in update mode in 2 different sessions, and I have read one file and I'm trying to read the same record in other session. So it will lock that particular file. And to avoid such issue, we use the extended N. So how it will work? Let me show you. First, what we will do? First, I will show you the error or locking, how the lock will come. So I am removing the N extender, saving the file, saving the program, and compiling it. The next session, in other session, I'm also doing the same thing, the same program. You can see I'm not using read and opcode here and putting this also into debug. So now the both program is on debug mode. So first I will call this program. Okay, let me put into debug. This it is not put on the debug. First we will copy the program name, that is op file op10, then strdbg, the library name, set the breakpoint, and we'll call it. So you can see the file is open in update mode. Okay. Now I have set my ID to 4, set the pointer, and read that particular record. So now I have already read the 4th record from my file. Now in other session, I also read the same record. ID is 4, set the pointer, and read the record. So you can see the program goes onto the wait. The file is been locked. It is not moving forward. You can see here X system. So file is been locked. How we can see the file is locked? Just use this command dsp rcd lck, display record lock. Your file name, that is file opr, your library name. You can see it is held. The lock type is update. We are doing the update operation and the file has been locked. And the second session is in wait because the first session, which was in update mode, has locked this particular file. So to avoid this type of issue, we use the read n opcode. So if I use read n opcode here, it will not give me the error. Let me end this debug on the both the session. Now change the source. Now what I will do, I will use the extender as n here to avoid the locking. Again, I will save it, compile it, and we'll put into debug. Same we'll do in the other session. So here also we have used read n. Put into the debug and call it. So in the first session, I have read that particular record. Now, in the other session, if I try to read the same record again, this time the file will not be locked because we have used read n opcode here. So if I press F10, you can see it has successfully processed the program and stored the name into a name variable, that is checkup. So using this opcode, the simultaneously users can use the same record, can read the same record in update mode without locking the particular file. So this is how the read and opcode will work. So yeah, that's all about opcodes in the file operation. So if anyone have any questions, so they can share your question in the chat box so we can answer those. In particular, we are also sharing the link for the assignment in the chat box, so you can go through it. And there is also a link for IBM ebook that programmers.io is published. So it is very useful for you. So you can go through it. And the assignment you can pick from here. We are also mentioning our YouTube link, so you can go there and can watch this session again. Let's come to the Q&A session. No, the file will not always open in the lock mode. If the file is mentioned in update mode, and in one session you have read that particular record, and in other session you have not used the n extended and you are again trying to read that file, that it will put in the lock. Please explain once again why it is required to do input operation at first, then go for update. So if you want to update the record, you have to mention that which record you want to update. You are not going to update all the records present in the file. You have to mention that this particular record I want to update. The name was John. Now I want to change the name from John to Mary. So you have to first have to read that particular John record. Then you can change the name from John to Mary. Same goes with delete opcode. Any other questions? We will come to the CL program later. So we'll talk about later. Suppose I want to delete only, what to be done in that case? If you want to delete your particular record, first, as I have mentioned, you have to you have to read that particular record. Then you can use your delete opcode to delete that record. So I think most of the question is covered. So we have one more session on the opcodes on the next Wednesday. So we'll talk about some arithmetic opcodes, some other opcodes that we have not covered, other methods of handling the error. So we'll talk about on our Wednesday session. So please join that session as well. Okay, so I think we are on time and there is no different questions I can see and no more question. So we can end up the today's session. Thank you everyone for the joining. Have a great day. Thank you.